Programming Skills using C, lecture number 21A, Recursive Functions. My dear friends, we have been dealing with quite a lot of function subprograms in C and how we saw how it is easy to convert all the programs we had written earlier into function subprograms, and we have done that. Now we come to one more topic called recursive functions. We are going to write some of those functions, rewrite some of those functions, but using what is called the recursive algorithm. So in this lecture, you will write more function subprograms using recursive algorithm. Now, what is recursive function or recursive algorithm? So recursive function is a function that calls itself during its execution. The process may repeat several times, outputting the result at the end, end of each iteration, and it is summed at the end. But please remember one important thing, that there should be at least one terminating condition. So that is very important to realize. So first, always whenever you want to write a recursive function, look for the terminating condition. What should be the termination condition? Well, let us take first example to find out the factorial of a given number. So general factorial n, as you know, factorial n we have written earlier. In our earlier method, we went on multiplying, starting with 1, 2, 3, 4 up to n. But here we have got the formula. N factorial is equal to factorial n minus 1 into n. So this is the formula we are going to use. Try to understand. Let us see. Here, what is factorial of 0? Factorial of 0, you know, it is 1. Now this becomes a terminating condition. What is factorial of 5? Factorial of 5 is equal to factorial of 5 into factorial of 4. So that is 5 is equal to factorial of 5 minus 1. 4 is 5 minus 1. With this we get our general formula. Factorial of n is equal to n into factorial of n minus 1. And then here factorial of n minus 1 is equal to n minus 1 into factorial of n minus 2. It goes on till we come to what is called the factorial of 0, which is equal to, then we return 1. So this becomes the general formula. So now the question is, how are we going to write this function? So factorial of n, that is equal to n into factorial of n minus 1. This is the formula. As I told you, this becomes the terminating condition. As I have told here, factorial of 0 is equal to 1. That becomes a terminating condition. They say if the value of n is equal to 0, you return 1. With that, it terminates. The whole process terminates. Otherwise, what do you do? Otherwise, you take this formula, multiply n by factorial of n minus 1. So this will be called again and again till n value becomes 0 when it is going to return 1. So this becomes my function, recursive function to find the factorial of n. Let us see how we are going to use it. In this function, in this program, I have written here n value is 10. I am just finding out the factorial. I plug in the value of n here. It returns the factorial of 10 here using the recursive function. This is the recursive function we have written. If n is equal to 0, return 1, or else it return n multiplied by factorial of n minus 1. So as I said, this becomes the recursive function to find the factorial of n. And here we give the prototype of the function, here we give the code of the function, and here in the main we are going to use this function. So for example, here factorial of 5. Factor of 5 is 5 into factorial of 4. Factorial of 4 is 4 into factorial of 3. It goes on and on, comes to factorial of 1 and factorial of 0. And in that case also it returns 1. Because 5, 4, 3, 2, 1 into 1 becomes 120. So this is how it is going to calculate the factorial of the number using the recursive algorithm. Let us take the second problem. Fibonacci numbers. You know, Fibonacci numbers are very, very important. Whole nature, it seems to be, mathematicians tell us that whole nature is based, the whole architecture even is based on this proportion given by the Fibonacci numbers. So here, for example, we have got how to, I think we have done this earlier, generating Fibonacci numbers. The first term, second term. We declare only first two terms and get the third term. That is what we did. Now let us see how we are going to generate these Fibonacci numbers using recursive algorithm. So therefore, Fibonacci 0 is equal to 0. This is going to be first our terminating condition. What is Fibonacci 1? Fibonacci 1 is equal to 1. Then what is Fibonacci 2? Fibonacci 2 also is 1 because it is Fibonacci 0 plus Fibonacci 1. What, as you see, Fibonacci 0, Fibonacci 1. What is Fibonacci 3? Fibonacci 3 is equal to Fibonacci 1 plus Fibonacci 2. So as we see here, therefore, general formula for us, what is Fibonacci n is going to Fibonacci n minus 1 plus Fibonacci n minus 2. So this becomes the recursive function. I'm calling it twice here in this function. These two are going to be the terminating conditions. So this is how, therefore, Fibonacci n is equal to, and if n is equal to 0, return 0. If n is equal to 1, return 1. Or what do you do? Else you return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So as you see in this function, I'm calling this function twice. I'm calling. So recursive, therefore it is a recursive function. So for example, here I've written a program here to generate n Fibonacci numbers. Please remember, this function generates the nth term of the Fibonacci numbers. That's all. It's not generating n Fibonacci numbers. So nth Fibonacci number. So therefore, I am going to have written this. This is the prototype here. This is the code for that function. Then I'm using this function n times, starting from I is equal to 0, I is equal to less up to n. So I am finding the Fibonacci number, printing that Fibonacci number. So this is how we are going to do. Therefore, this function generates, please remember, the nth Fibonacci number. And here we have got example here. Therefore, Fibonacci 0 is equal to 0, Fibonacci 1 is equal to 1, 2 is equal to 1, 3 is equal to, goes on like that. 10, you can go on printing all the Fibonacci numbers. So this is generating Fibonacci numbers using recursive function. With that, we go to one more function to generate sum of natural and odd series using recursive functions. So I am going to do sum of natural numbers. For you have to think about generating the odd series using recursive function. That is sum of odd series. Now sum of natural series, you have got the natural series here, 1, 2, 3, 4, 5 up to 9. So therefore what is? Suppose I write this function called sum nat n. If it is 1, what? It is going to return, if n is equal to 1, return 1. What is the sum of 5? Sum of natural number 5 is going to 5 plus sum of natural numbers 4. That is equal to 5 plus 4 plus a function sum of nat 3. This goes on like that, 2, then 1, then this equal to the terminate. This is the terminating condition. So that is equal to 1. As you see, automatically they are added. Sum is found. You see it is 10. 15 is going to be the answer. So general formula therefore is equal to function sum natural n is equal to n plus function sub n minus 1, as we have done earlier. That was, there was multiplication to find the factorial. Is only adding plus. So this becomes our terminating condition, and this becomes the general formula in finding out the sum of natural numbers. So I've given here sum of natural numbers. I've written here function for sum of odds, but here sum of natural numbers. So we use that to generate n, sum of n is equal to 10. It is going to give us the sum of first 10 natural numbers. So that is what it is going to do. I would like you to write that and execute that program. With that, we come to the next recursive function. Recursive function to find the result of a number raised to some power, x to the power n, x to the power n. How are you going to do recursively? In our ordinary way, we will go on multiplying x n time. So as you see here, for x of 0 is equal to 1, this becomes my terminating condition. X to the power 1 is equal to x into 1. X to the power is equal to 2 is equal to x into x. 3x goes on like that. As you see, x is equal to x into x to the power 2. X to the power 4 is equal to x into x to the power 3 goes on. This becomes my general formula. x to the power n is equal to x into x to the power n minus 1. So we have to use this general. So always therefore first find the terminating condition and find the general formula in terms of the function itself. So therefore power x comma n is equal to x into power n minus 1. This becomes the general formula. So if x n is equal to 0, this is n value here, equal 0, return 1. This is the terminating condition. Otherwise what you do? Otherwise you multiply x into x to the power n minus 1. This is the algorithm I have shown, but here it is going to be therefore return therefore x into power x to the power n minus 1. So this becomes power is my function, and as you see here, x int here I should be small there. Unfortunately, it's become uh, so function power xn. Therefore, if n is equal to 0, return 1, or you return x into, you call that same function but with the argument x minus n minus 1. So this is for raising the power, positive power. But there is a negative power, x to the power minus 2. What happens? So then you need to write one more part here. If n is equal to greater than 0, then it becomes this. Greater than equal to 0 is becomes this x into function power x n minus 1 as here, but it is less than 0. If it's a negative, then naturally x will go into the denominator. Therefore 1 divided by x into function same, but in this case you say n plus 1. N plus 1, we have to go on decreasing. N minus 5 becomes n minus 4, n minus 3, n minus 2, n minus 1, n minus 0. Therefore that is to be remembered. Therefore this is becomes n plus 1. So this therefore is the recursive function to generate the power of or x to raised to the power n, x raised to the power n. Here n may be positive number or a negative number. So for example, I have given you the whole program. Prototype is here. Then this is the code for the function, and this is the use of the function. We are doing it here, and the result is given here. For example, 2 to the power 5 raised to 2 to the 5, 2 into 2 into 5 times gives you 32. 2 to the power minus 2 means 2 divided by 4. 2 divided 4 is 0.25. So 2 to the power 2. So that is 2 to the power minus 2 means 1 divided by 2 to the power 2, that is equal to 0.25. This is the answer. So therefore this is the recursive function to generate the power x to the x raised to the power x to the power n. So that is what we are going to do. And with that we come to a last recursive function. There are many more, but you should be able to write those functions. So write a recursive function to find the length of a string. We have done that non-recursively earlier, where we said as long as I have not reached the end of the string, that is null, s of I is not equal to null, you go on incrementing the value of I. So therefore our terminating condition is if s of I is equal to null, then for I say that means I have come to the end, therefore return the total value of I. Otherwise, what you do? Otherwise, you increment the I and call this same function again and again, again and again, till it becomes s of I becomes null. So then this is therefore the algorithm. So I am calling the same function again. So here character s, I have just put s here. So I am calling the function again and again till the s of I becomes null. Please remember here, static. If you don't declare this as static, it is not going to work, because this I value will not increment inside this function, because this I is here, this I has some other value here. Every time it is going to be 0. Therefore, static, you have to use this term static int I. That means 0. When it gets in here, that I becomes 1. Then again I becomes 2, 3, 4, etc. For example, here 0, 1, 2, 3, 4, 5, 6, 7. When I becomes 7, it comes out of terminates, and therefore I has 7. It is going to return the value of I here. Return I here. I will be 7. So this is therefore recursive function to find the length of a string. Thank you.